Today we will learn triangle and its parts and the different types of triangles based on sides and angles. A simple closed figure made of three sides is called a triangle. The triangle is the polygon with least number of sides. You must have seen this type of sign on the road. We call it a triangle. Similarly, in daily life, we see many things that give us the appearance of the shape of a triangle, some of which are shown here. Pause the video and think about these. Let us join three line segments and make a triangle like this. These line segments are called its sides. The point at which two sides of a triangle meet, that point is known as a vertex. Any triangle has three vertices. Let's name them A, B, and C. A triangle is named using the name of the vertices. Like here, we will name the triangle ABC. In order to name any triangle, we start from a point and moving from one point to another, we write them in sequence. Like here, we have named the triangle ABC, this symbol of a triangle. This sign of a triangle indicates that we are talking about a triangle named triangle ABC. Since we can start from any point and move in any direction on the boundary, we can also give the name of this triangle BCA, triangle CAB, triangle ACB, triangle BAC, or triangle CBA. We can see that triangle ABC is made of three sides, the side AB, side BC, and side CA. This triangle has three angles. These are named angle A, angle B, and angle C. To describe them more precisely, angle CAB, angle ABC, angle BCA can be their names. Now, if we see, here BC is the side opposite to angle A. Similarly, AC is the side opposite to angle B, and the side opposite to angle C is AB. Similarly, we call the inner part of the triangle as its interior. This is its boundary. The part outside the boundary is called the exterior of the triangle. We can make different types of triangles. We can classify them on the basis of sides and on the basis of angles. Let's classify triangles based on the sides. Look here. Triangle ABC has AB is equal to 5 cm, BC is equal to 6 cm, and AC is equal to 7 cm. A triangle whose three sides are not equal is called a scalene triangle. Now observe this. Triangle PQR has PQ is equal to 5 cm, QR is equal to 5 cm, and PR is equal to 7 cm. Here PQ is equal to QR. A triangle with only two sides equal is called an isosceles triangle. In a triangle, we can show two equal sides using the same sign in this way. Now, if we talk about triangle LMN, then it has LM is equal to MN is equal to LN is equal to 5 cm. That is, all three sides are equal. A triangle whose three sides are equal is called an equilateral triangle. Now, will you be able to classify the given triangles on the basis of its sides? Try it. Let us tell you. These different signs on the sides of triangle ABC tell us that the three sides in this triangle are not equal, so it is a scalene triangle. By looking at triangle DEF, we find that the measure of side DE and side EF is equal, but the measure of third arm DF is not equal to them. Since only two sides of this triangle are equal, it is an isosceles triangle. Triangle XYZ has the same sign on all the three sides, so we can say that its three sides are equal. Hence, it is called an equilateral triangle. In triangle PQR, the measurements of the three sides are not equal, so this triangle is a scalene triangle. We can also classify triangles on the basis of angles. You must remember that an angle smaller than 90 degrees is called an acute angle. An angle of 90 degrees is called a right angle. And if the angle is more than 90 degrees but less than 180 degrees, then it is called an obtuse angle. Now, let's classify triangles based on angles. A triangle with all angles acute is called an acute angled triangle. A triangle that has a right angle is called a right-angled triangle. Keep in mind, the right angle is represented this way. Similarly, a triangle with an angle greater than 90 degrees but less than 180 degrees is called an obtuse angled triangle. Now, will you be able to classify the given triangles based on angles? Try it. Let us tell you. Triangle ABC has a right angle, so it is a right-angled triangle. Triangle DEF has an obtuse angle, so it is an obtuse angle triangle. Triangle PQR has obtuse angle, so it is also an obtuse angle triangle. Triangle MNO has all three angles acute, so it is an acute angled triangle. If we talk of triangle XYZ, then all its angles are 60 degrees. That is, it is an acute angle triangle. If we measure its sides, we will see that its three sides are equal. This shows us that it is an equilateral triangle. We can say that in an equilateral triangle, every angle is 60 degrees. Today we learnt about triangle and its parts and the types of triangles on the basis of sides and angles. In the next video, we will see some examples related to it. Understanding more about the triangle and its parts, today we will learn about the median of a triangle. Here we have a triangle made of paper. Suppose we have to find the midpoint of this side. Can you tell us how to do this? Think about it. To find the midpoint of this side of a triangle, we fold the paper in such a way that the two vertices of this side cover each other. We will draw the crease. The point where the crease intersects this side of the triangle is the midpoint of this side. Now, if we connect the midpoint of this side with opposite vertex, then we will get a median of the triangle. The median is the line segment that connects a vertex of a triangle to the midpoint of its opposite side. We can also draw median in a triangle by construction. First, we will draw a triangle and name it triangle ABC. Suppose here we need to find the midpoint of the side BC. Can you tell how the midpoint of the side BC can be found? Think about it. Let us tell you. For this, we will construct the perpendicular bisector of BC. We will do this in the following way. We will take more than half the distance of the side BC in the compass. Then we will put the pointed end of the compass on the vertex B. Assuming B as the center, we will draw an arc that is above and below the side BC, without changing the radius. Taken in the compass, assuming point C to be the center, we will draw an arc over the side BC, which will intersect the arc formed with point B at point D. Similarly, we will also draw an arc under the side BC, which will intersect the already formed arc at point E. Now we will join these 2 points so that we get the perpendicular bisector of the side BC. Suppose here the perpendicular bisector intersects the side BC at point H. In this way, point H will be the midpoint of the side BC. Now if we connect the midpoint H of BC to the vertex A opposite to BC in this way, the line segment obtained will be called a median AH of triangle ABC. We can say that the line segment that connects a vertex of a triangle to the midpoint of its opposite side is called a median of the triangle. Can you tell how many medians a triangle can have? Think about it. Exactly. Joining these vertices with the midpoints of their opposite sides, we can get 3 medians. That is, any triangle will have 3 medians. Will they always be in the interior of the triangle? Find out the answer to this question yourself by drawing a triangle and its median on the paper. Today we learned about the median of the triangle. In the next video, we will discuss about the altitude of the triangles. Understanding more about the triangle and its parts, today we will learn about the altitude of a triangle. Sometimes in a triangle, it is necessary
to find the distance between a vertex and its opposite side.
Suppose we are given triangle PQR and have to find its height. That is, we have to find the distance between the vertex P and the side QR. To find the distance, we can make line segment in different ways. Do all these give us the correct information about the distance between the vertex P and its opposite side QR, or say the height of the triangle? Think about it. No, not all of them give us correct information. From the vertex P, to find the height of a triangle, we draw a perpendicular to its opposite side QR, which intersects the side QR at point J. A perpendicular drawn from a vertex to its opposite side is called an altitude of the triangle. Here, line segment PJ is an altitude of the triangle PQR that forms a right angle on the side QR. This gives us the distance between the vertex and its opposite side. That is, height of a triangle. Now let's learn the method of making altitudes. Step 1. Suppose we have to draw the altitudes of the side BC from vertex A in triangle ABC. Step 2. For this, we will draw an arc from point A to the side BC by taking a convenient radius in the compass, which will intersect the side BC at point D and E. If necessary, you can extend the opposite arm from the vertex. Step 3. Without changing the radius in the compass, with the points D and E as centers, we will draw 2 arcs cutting each other in the side opposite to the vertex A. Suppose both arcs intersect at point F. Step 4. Now we will connect A to the point of intersection F. AF is perpendicular to BC. Suppose line segment AF intersects BC at point P. The new line segment AP is the altitude from vertex A to opposite side BC. Just imagine how many altitudes a triangle can have. Absolutely right. Just as we have created altitudes from vertex A to side BC, similarly, we can also draw altitudes from vertex B to side AC and from vertex C to side AB. That is, a triangle can have 3 altitudes. Since this is an acute triangle, you can see that all altitudes are in the interior of the triangle. Now you can take a paper and draw obtuse angled triangle on it. Draw all the altitudes in it. Do you get all altitude in the interior of the triangle? Find out by pausing the video. If we talk about an obtuse angled triangle, we can draw altitudes in this way. As you can see, the altitudes in an obtuse angled triangle can also be in the exterior of the triangle. Similarly, if we talk about a right-angled triangle, then its two sides are perpendicular to each other. This means that both the sides are also the altitudes of the triangle. And the third altitude can be obtained at the hypotenuse of the triangle by drawing a perpendicular from vertex to it. Today we learned about the altitudes of a triangle. In the next video, we will see examples related to the parts and types of triangles. Today we will see examples related to triangle and its parts. Example: classify the given triangles on the basis of their sides and angles. If we talk about triangle PQR, the measurement of the three sides of this triangle is different, so it is named on the basis of the sides. This triangle is called a scalene triangle. We can see that the angle PRQ in it is a right angle.
So, based on the angles, it will be classified as a right-angled triangle.
Seeing the figure of triangle EFG, we find that the two sides of this triangle are equal. So it is an isosceles triangle. Since one of its angles, angle GEF, is greater than 90 degrees, hence it is an obtuse angle, therefore it is an obtuse angled triangle. Next example. Identify the parts indicated in the triangle LMN. Here we are given triangle LMN. Observing the triangle, we know that its vertices are L, M and N. Sides are LM, MN and LN. And its angles are angle LMN, angle MNL and angle NLM. Now if we see, here the side MN is opposite to the vertex L. That is, MN is the opposite side of the vertex L. Similarly, the vertex and the opposite side pairs is the vertex N and the side LM and the vertex M and the side LN. As you can see here, the line segment LK is made on the opposite side MN from the vertex L. Here, from this sign, we get to know that here angle LKN is equal to angle LKM is equal to 90 degrees. That is, the line segment LK is perpendicular to the side MN of the triangle. We know that a perpendicular drawn from a vertex to its opposite side is called an altitude of the triangle. In this way, LK is an altitude of triangle LMN. Similarly, we can see that the line segment NJ intersects the side LM at point J. If we look at line segment LJ and line segment JM, both are marked with the same symbol. Can you tell me what do they mean? Think about it. Absolutely correct. Here these signs tell us that the length of line segment LJ is equal to the length of line segment JM. That is, the point J is the midpoint of the side LM. Since the line segment NJ is connecting the vertex N with the midpoint J of its opposite side LM, NJ is a median. The line segment that connects a vertex of a triangle to the midpoint of its opposite side is called a median. In this way, we have identified the parts of triangle LMN. Next example. In the equilateral triangle PTS shown here, TQ is the median and TR is the altitude. Find which of the following statements is correct. As you must know, a line segment that connects a vertex of a triangle to the midpoint of its opposite side is called a median. Since the line segment TQ is the median here, we can say that point Q is the midpoint of the side SP. That is, SQ is equal to QP. You can see SQ is equal to QP is given explicitly in the first statement, so we can say that the first option is correct. Now let's talk about the second option. Suppose the lengths of line segment SR and line segment RP are equal. As you can see here, SR is smaller than SQ. If this option is correct, then we can put RP in place of SR. Similarly, as we saw, SQ is equal to QP, so we can put QP in place of SQ. Then tell us, is inequality RP smaller than QP true? Think about it. Absolutely right. It is not true. Looking at the figure, we can say that RP is greater than QP here. From this, we can say that SR is equal to RP is an incorrect option. For the third statement, we need to understand the altitude. A perpendicular drawn from a vertex to its opposite side is called an altitude of a triangle. In this way, we can say that angle TRP is equal to 90 degrees. That is, the third option is correct. Only one perpendicular can be drawn on a line from a vertex. Since we have obtained this perpendicular TR from the vertex T, there can't be any other line segment which is perpendicular to side SP from the vertex T. In this way, we can say that angle TQP cannot be equal to 90 degrees. Hence, the fourth option is incorrect. So today we saw examples related to triangle and its parts. In the next video, we will see some misconceptions related to them. Today we will see some misconceptions related to the triangle and its parts. Misconception 1. Can the median of a triangle be equal to the altitude? Often in the examples, the median and the altitude are represented by different line segments, because of which children believe that the median and the altitude are always two different line segments. Therefore, children begin to assume that median and altitude of triangle can never be the same. With this understanding, they give the wrong answer and select option 1. Let us understand this with an activity. We draw an isosceles triangle PQR, on a paper. You can see that the sides PR and QR are equal. Now we will cut this triangle. Now we will fold this triangle forming two equal parts of the side PQ. While doing this, ensure that the crease formed on side PQ passes through the vertex opposite to it, that is vertex R. The crease obtained is a line segment that divides the line PQ into two equal parts, so we can call it the median. If we place the protractor properly at the intersection of this line segment and the side PQ, then we know that this line segment makes an angle 90 degrees on PQ. Since this line segment is a perpendicular from the vertex R on its opposite side PQ, we can call it an altitude. Thus, we can say that in a triangle, the median and the altitude can be equal. So, option 2 is the correct answer. Similarly, you draw an equilateral triangle and find whether the median and altitude in it are equal or not. Misconception 2. The teacher made a scalene triangle on the board and asked the children, how many altitudes can we get in the given triangle? To this, Rahul replied 1 and Kajal replied 3. Find out who gave the correct answer. Some children are well aware that the perpendicular, which is formed on the opposite side of any vertex, is called the altitude of the triangle. In the given figure, some children are only able to make an altitude on the side BA only from the vertex C. So they think that only one altitude can be obtained in the given figure. With this understanding, they answer option 1, which is a wrong answer. The correct understanding is that the altitudes can be inside the triangle and also outside. For example, if the side BC is extended here, an altitude can be made from the vertex A in the same way. Similarly, if the side AC is extended,
An altitude can be made from the vertex B.
in this way. In this way, we can draw 3 altitudes in any triangle. Hence, the understanding of Kajal is correct, that is, option 2 is the correct answer. Today we saw some misconceptions related to the triangle and its parts.